In this video, we're going to look at the questions number 4 to 10 in exercise 3b. So question 4, a projectile fired from a point O on a horizontal plane. Initial velocity is 3i plus 4j meters per second. Find the vertical height when its horizontal displacement is 1/5 of its range. So we need to find the range here, and then find another time when its height is equal to this height. So the range, excuse the drilling in the background if you can hear it, the range is equal to s of x, which is equal to ut, no acceleration, so the at squared is 0, and my initial velocity for x is 3, so 3t. So we need the time that it takes this projectile to get to here. So s of y is equal to 0. And then we need 2 times, so we're looking at 1/5 of the height here, and it's obviously going to be over here at 4/5 due to the symmetry of these quadratic curves. So s of y is equal to ut plus a half at squared. S of y is equal to my initial u, which is 4t, minus 4.9 t squared. So if we let this equal 0, 4t minus 4.9 t squared is equal to 0. Factor out my t or my 4t or 4.9t, whatever way you want to do it, you'll get the same answer. That's going to leave 4 minus 4.9t inside the bracket. So this is my initial time of 0, and 4.9t is equal to 4, so t is equal to 4 over 4.9, or 40 multiplying it by 10, 40 over 49. So my range s of x is equal to 3 times 40 over 49, which is equal to 120 over 49. I think when they work out like this, there's no point in decimalizing them when they're working out nice and evenly like this. Now, what are we looking for? We are looking for the vertical height when the horizontal displacement, so from here to here, is 1/5 of the total range. So that's the total range, okay. So 1/5 of range is equal to 120 over 49 multiplied by 1 over 5. 5 divides into 120 24 times, so that's going to be 24 over 49 meters. That's 1/5 of the range. And we're looking for the time. Just go back up. We're looking for the vertical height when its horizontal displacement is 1/5 of the range. So we're looking for this vertical height here along this line here. So s of y is what we're looking for. So we need to find how long does it take to get from here to here. So we know that's in displacement terms in x, s of x is equal to 3t. So 3t is equal to this 1/5 distance on the bottom, 24 over 49. So we're going to get, if we bring the 3 underneath and divide 24 by 3, we're going to get 8 over 49. And that will be seconds. So we want our displacement in y at this time. S of y is equal to my initial velocity, which was 4 up here. So ut plus a half at squared, you're going to keep writing it, is equal to 4 times 8 over 49 minus 4.9 by 8. I'll just get rid of that. 8 over 49 to be squared. And just type this into your calculator. 4 by 8 over 49 minus 4.9 by 8 over 49 to be squared is giving me uneven. It's working out as an even fraction. 128 over 245 meters. So another time when the height is the same, so we're looking for in here and here, that's 1/5 of the range. So this has to be 4/5 of the range. So let's get 4/5 of the total range. So the total range is time is 40 over 49. So 4/5 of 40 over 49, it's going to be 32 over 49. 5 into 40 goes 8 times. So 32 over 49 seconds is the other time when the height is going to be the same. Question 5, you're asked to factorize 7t squared minus 20t minus 500, and then you're told a cannon fires a cannonball from the top of a cliff 350 meters high. Do a diagram as you're reading this question. Above sea level with initial velocity 10I plus 14J meters per second, and find the distance from the foot of the cliff where the ball hits the sea. Okay, it's going to come down like this and hit the sea down here. So what can we say about S of Y at this point? S of Y is minus 350. Be careful with these ones that are at the top of a cliff that you don't put in a positive distance. Now I'd imagine that this is going to link to part 2. 7t by t is the only way to get 7t squared. 500 is 50 by 10, and you can see actually that it's going to give it to us 50 by 10. There's 70 and there's 50 to give me this minus 20. We want minus 20, so it has to be minus 70 plus 50. So if we were to solve this, t is equal to, now this is going to be time in the second part, it has to be minus 50 over 7, which it can't be a negative time, or 10 seconds. So it looks like this cannonball, it's going to take 10 seconds to hit the sea. Let's just calculate it in here. So I have 10I plus 14J. We want S of Y to be equal to 0. S of Y is equal to UT plus a half AT squared. That's going to be equal to minus 350. My initial velocity for Y is 14 minus 4.9 T squared, and then plus 350 equals 0. So I'm going to get 4.9 T squared minus 14T minus 350 equals 0. Multiplying by 10, 49T squared minus 140T minus 3500 equals 0. And then I can divide by 7. This should give me the original quadratic. 7T squared minus 140T minus 500 equals 0. Minus 7T squared minus 20T minus 500 equals 0. Okay, so we've already solved it. We can say T is equal to 10. Therefore, the range, which is equal to S of X, which is equal to the point at which the cannonball hits the sea, is equal to UT because of my zero acceleration in the I direction. My U is 10, so it's equal to 10 times 10. So this cannonball goes 100 meters before it crashes into a ship and makes it explode. In question 6, you're told the particle is fired from a point on a horizontal plane with an initial velocity 50I plus 49J. Find range. So we're looking for S of X. So again, just do a diagram. I'm sure it only takes a second. This is my S of X. And we want when S of Y is equal to 0 to get the time. Time equals. So S of Y is equal to UT plus a half AT squared. My 49 is my U, so 49T minus 4.9T squared is equal to 0 at this point in here. So we're going to get, well, I can just factorize, I'll take T out and write 49 minus 4.9T is equal to 0. This is my initial, T is equal to 0, or 4.9T is equal to 49, T is equal to 10. So my range S of X is equal to 50T, which is equal to 50 times 10, which is 500 meters. In question 7, we're told a particle is projected with initial speed 35I plus 14J meters per second from a point on a horizontal plane. Find its max height, and then find the times at which the height above the horizontal is 3/4 of max height. Okay, again, the diagram. We've got our max, and then we've got when it's 3/4 of the max along here. So we need the max height to get 3/4 of the max. What can we say about at the max height? The velocity of Y is equal to 0. V squared is equal to U squared plus 2AS will give us this. You could say S is equal to H, as it does in the book sometimes, but just I'm going to leave it as S. So V is equal to 0. 0 squared is equal to my initial 14 squared, which is 196 minus 19.6S. And you can see this works out evenly to be 19.6S is equal to 196. So S is equal to 19.610. So the max height is 10. So 3/4 of max is equal to 7.5. So that's equal to S of y. So we put that into the S of y formula. S of y, displacement in y, ut plus a half at squared is equal to 7.5. And we're asked for the times. Obviously there's two of them because of this symmetry, which the height above the horizontal plane. So my initial 14t minus 4.9t squared is equal to 7.5. So if I bring the 2 to the right, I'm going to get 4.9t squared minus 14t plus 7.5 is equal to 0. So if I multiply them by 10, let's see, there's a factorized 49t squared minus 140t plus 75 equals 0. So I have a minus and a plus, so they both have to be minuses. And it's probably 7t by 7t if it factorizes. Now, if it doesn't factorize, which some of them in this topic don't, we just go straight to our calculator with the quadratic formula. And actually, when you get good at it, it's probably quicker than factorizing. Now, it could be 15 by 5 for 75 or 25 by 3. It doesn't look like it's 25 because I go above 140. So let's try 15. They're both 7, so it doesn't matter which bracket they go in. This doesn't work. I can rub it out, but you just go on to the next line and try it again. So 7 15s is 105 and 5 and 35, so it does work. That is going to give me 140, 35 and 105. So t is equal to 5 over 7 or 15 over 7. And that's all we were asked for, the times. So that's the answer to question 7. Question 8, we're told a particle is projected from the top of a vertical cliff 82.5 meters high with initial speed 12I plus 8j. How far from the foot of the cliff will it hit the sea? Okay, so similar to question 6, 82.5. We know at this point S of y, well, will be equal to 0 minus 82.5 because it's starting up here. So we need a time taken to get there. How far from the foot? So we're looking for S of x along here. So we're looking for the range. So we need the times when time taken. S of y will give me the time, ut plus a half at squared is going to be equal to minus 82.5. My initial velocity is 8 in the y direction, so 8t minus 4.9t squared plus 82.5 is equal to 0. So 4.9t squared minus 8t minus 82.5 is equal to 0. So one's a plus and one's a minus here. So one solution can't work. Now, does it? I multiply them by 10. I don't know if this factorizes 7 sevens, and I've messed around a little bit. I can't see a direct factorization. Maybe you guys can't. So I'm going to type this into a calculator. 80. Now the minus part won't work because you can see it's going to be with the signs 1 plus 1 minus. So 80 plus the square root of b squared, 80 squared minus 4 by 49 by minus 825, which is giving me a plus there, otherwise this wouldn't work, over 2 by 49. I'm getting two answers here. I'm getting my plus answer first. I could go back and change it to the minus answer, but my plus answer here actually does work out even, so maybe it does factorize. I'm getting t is equal to 5 here for my time. So S of x is equal to ut, which is equal to 12 by 5, which is 60 meters. That's question 8. Question 9, we're given a particle is projected horizontally from the top of a vertical cliff 78.4 meters high. Now, if it's projected horizontally in this direction, it means there's no j. Horizontally, no j. That's 78.4 meters high. So my initial velocity vector is going to be the speed 98 in the I direction plus 0 in the j direction. And it's 78.4 meters high. So how much time will pass? Let's have a look at this. So time, we always know we're using S of y is equal to minus 78.4, the time taken to get here, which is what they're asking for, the time. So S is equal to ut plus a half at squared equals minus 78.4. Now there is no initial u here, there's no initial velocity in the j direction because of the horizontal projection. So minus 4.9 t squared is equal to minus 78.4. So 4.9 t squared is equal to 78.4. Now 78.4, that 4.9 definitely goes into that because 16 5s are 80, so it's 1.6 less than 80. So that's 16 4.9s. T can't be negative, so t is equal to 4. How much time will pass? So that's the first question, 4 seconds. If the angle is raised to 30 degrees, okay, now this is the first time in exercise 3b that we've seen these angles. So let's have a look. If the angle is raised to 30 degrees, so it's now being projected in this direction at 98 meters a second. And my angle in here is 30. So my initial velocity vector is going to be 98 cos 30 in the I direction plus 98 sine 30 in the j direction. Now the cos of 30 is root 3 over 2, so the initial velocity is equal to 98 by root 3 over 2 in the I direction plus 98, and the sine of 30 is a half in the j direction. So my initial velocity is 49 root 3 in the I direction plus 49 in the j direction. And we're asked the time again for, so it's the same distance. So how long will it take to reach the ground? So same again, S of y is equal to minus 78.4. My y now has this, so ut plus a half at squared is equal to minus 78.4. So my 49t minus 4.9t squared plus 78.4 equals 0. Now there's a clue in the question, they tell you one decimal place, so this is definitely the quadratic formula. 4.9t squared minus 49t minus 78.4 is equal to 0. You can see what my minus is. One of them is going to be a minus, one's going to be a plus. So just on your calculator type in minus b 49 plus the square root of b squared, 49 squared minus 4 by 4.9 by minus 78.4, and divide that by twice 4.9. You could multiply by 10 and get rid of the decimals, so it doesn't make a difference. So this is giving me 11.4 seconds. Correct one decimal place. Okay, first one with an angle. Let's look at number 10. Question 10. A particle is projected with velocity 50 meters a second at an angle theta to the horizontal, where cos theta is equal to 3 over 5. Right, once we see tan theta or cos theta or sine theta, cos is equal to a over h. So that's a 4. We're going to need sine theta is equal to 4 over 5. Work out the other variables straight away. Express the position vector or of the particle after t seconds in terms of I and j. Okay, well let's look at the initial velocity of this particle. We have our angle, so it's going to be my speed 50 by the cos of theta in the I direction plus 50 sine theta in the j direction, which is equal to 50 by 3 over 5, or 60% of 50, 30 in the I direction plus 80% of 50, which is 40 in the j direction. So that's my initial velocity vector. So the position vector, or what I need is, where is this after t seconds? So my position of x, or I, is equal to ut, which is 30t, and my position of y is equal to 40 ut plus a half at squared, 40t minus 4.9t squared, depending on t. So that we're looking for or, so we can write or actually in terms of t. Or is equal to 30t in the I direction plus 40t minus 4.9t squared in the j direction. That's what they're looking for in part 1. In part 2, the magnitude and the direction when t is equal to 1. Okay, well when t is equal to 1, we're looking for the velocity here. We're looking for the magnitude. So the velocity is equal to u plus at. So my velocity in the I direction is just my initial 30, and my velocity in the j direction is equal to 40 minus 4.9t. Sorry, minus ut, my at, so minus 9.8t. We're talking about 1 for t. T is equal to 1, is that what they told us? T is equal to 1. So that's going to give me 30.2. So we can say that the velocity at t is equal to 1 is going to be 30 in the I direction and 30.2 in the j direction. Now the magnitude of this, that's the velocity vector, the magnitude of this is from before the square root, 30 squared plus 30.2 to be squared. And that is giving me is it correct to the nearest meters per second? So it's giving me 43 meters a second, and the angle theta is equal to the inverse tan of 30.2 over 30. Well, that's nearly 1. 30.2 over 30, so it should be 45. And yes, it is 45 degrees. So part 3 of this question, we're asked for the horizontal range. Which is equal to s of x. So we need that when s of y is equal to 0. So my ut plus a half at squared is equal to 0. So my 40t minus 4.9t squared, you may have heard the bell, is equal to 0. So t by 40 minus 4.9t equals 0. So my initial t is equal to 0. And 4.9t is equal to 40. T is equal to 40 over 4.9. Or 400 over 49, whatever you'd prefer. So s of x is equal to my u, which was this 30 times t, 30t, which is equal to 30 by 400 over 49, which is 12,000 over 49. And as a decimal, that's given me, correct the 1 decimal place, 244.9 meters. So that's question 10.